Okay, for those who are going to watch this recording, I'm just going to let everyone load in from the waiting room. So I think we'll start to let people load in here in a second. I'm going to go to the waiting room. And yeah, I'm excited. Hello, everyone.
Morning.
Hi, everyone. I'm just going to let anyone come in off of the waiting room here. So we'll get started shortly. Super excited for this. You can have, make sure you're muted. Feel free to have your camera on or off. It's totally up to you. I will also make sure all of us are muted here in a second. So excited. All right. I know some of you who have been with me for a couple of times know I'm a big nerd here with this stuff. All right, let's see. Okay, good. I will just continue to admit. Welcome. Hi, everyone, to the Quantum Basics webinar. This was this idea was given to me by some of you, right? Because people are like, well, you know, we like what you're talking about, but we want to know more. And so there's only so much room that 2,200 characters gives you in an Instagram post. And so I'm really excited to be able to kind of dive into this a little bit differently and a little bit deeper today. And so I just in general, right? Some of you have been with me for a while. Some of you are just starting to get to know Carrie, me. So I'm Carrie Bennett. I am over here in Kalamazoo, Michigan. And gosh, I have been in the health field for a long time now, since, you know, I'd say forever, because I was always an athlete. I was always interested in, you know, what can I do to better myself? And within the past 5 years, the quantum world got me hooked. I became so interested in the foundation of health, and I started to want to go deeper. It's like, what is it? Is it, as a college athlete, it was exercise, you know, and then I went into massage therapy school, and it was massage. And I went into, you know, I got really, really horrible gut issues when I had my first kid. And so it was obviously gut health and nutrition. And little by little, I've just kind of tried to figure out what's foundational when it comes to this. And this world of quantum biology, I got hooked into it about 5 years ago when I read my first Jack Kruse article, and understood maybe 10% of it, maybe. And ever since, I've just been exploring different angles, right? Like, how does quantum biology intersect with us in human health? And what can we do? Like, what are the practical applications of all of this research and all this information? So yeah, feel free. I see a couple of you talking, you know, I see some of you, where are we from? Monterey. Great. Yeah, feel free to say where you're coming from. I know we're from all over the world. So for some of you, good Monday morning. For others of you, hello. You know, I know it's the evening for some of you, and for me here, it's 1 p.m. in the afternoon, and it's a gorgeously snowy but sunny day. So hope you're all doing well wherever you are. I'm going to share my screen, and we'll get started in the presentation, and I'll kind of talk about how we go from there. So welcome. Hi from Germany. Woohoo, wonderful. Okay. All right. Hopefully, please let me know if you can't see my screen. Otherwise, the way that you know, these types of presentations work best in general is I like to save the questions for like set time slots. So you're more than welcome as we go to write questions into the chat. And so that way you don't forget them, and I can go through them when it's a time for a question break, or otherwise you can save them until that break. But this presentation will have about 3 different spots where we'll be going over, you know, you can ask whatever questions, right? And so the topics that we're going to kind of talk about more specifically are light, and lots of aspects of light, lots of aspects of water, which you know is one of my favorites, and then also mitochondria. But there's more to it, right? There are so many more ways that we can talk about quantum health, the quantum world, how the fields of energy that are literally in us and around us, how they interact with us. But I just figured that this would be a really good starting point to kind of get us into the topic of quantum health. And I wanted to let everyone know that I look at this, and this doesn't have to make any sense, but I look at this from something called a quantum electrodynamics perspective, which basically means I am not a trained quantum I've never taken a college course in quantum physics, quantum mechanics, any of those things. What I've done is I realized that I want to understand how my body interacts with quantum information. And so that's what the quantum electrodynamic field theory is. It's how does light, how does electromagnetic fields, how do they interact with the body? How do they interact with matter, which is basically me, right? I'm made up of matter. And what does that mean? And how can I maybe modify that, manipulate that in order to just maximize my health? So yeah, let's go from there. And as a heads up, right, this is not medical advice. And you know what, I am going to, can everyone just really make sure they're muted very quickly here? I'm sure there's a way that I can manage participants. Okay, so just let me go back to that slide previously. That slide was just basically saying that this is not medical advice, right? This is not, I don't treat, I don't diagnose, you know, we're not preventing anything here, right? This is for information purposes only. If you do like some of the information and you want to apply it, please do so with consulting your trusted health professionals first. All right. Light, light, okay? And throughout this presentation, you'll see various, you know, I'll put a couple of posts that I have done on Instagram. So maybe you can go back to that, take a screenshot of it, go back and read and kind of get maybe a different layer of information from these particular, from once you learn this information on a slightly different level. So light, what is light, right? You know, when I think of light, I think of sunlight. But that just makes up the tiniest spectrum of light that's actually in my world, in our environment. And so if we look at what this figure shows here is that we see that we've got visible light where if we were to shine sunlight through a prism, it would divide itself up into the rainbow of colors. And each rainbow corresponds to a different wavelength, it's called, right? And so you'll hear me talk about wavelengths and frequency. It's just a measurement of light. And whenever a light gets measured a certain wavelength or a certain frequency, it corresponds to a specific color. And so you'll see that we've got invisible light. There's wavelengths that are longer towards the red side, and then there's wavelengths that get shorter towards the violet side. And that's just visible light. And visible light is light that we physically can perceive, right? We can perceive it because my brain captures those specific wavelengths of light and then makes it into an image in the back of my brain, right? And so it's like I suck in light into my eyeballs convert that into some sort of an electrical message through my brain, and it becomes what I see in my world around me. And so that's why we call that visible light. And there's a lot of parts of the visible spectrum that we interact with, and we're going to talk a little bit more about that. But I do want you to know that light is also the infrared spectrum that I've mentioned before, right? Like, so I talk a lot about infrared. It's ultraviolet. So the UV, UVA, UVB, but it's even X-rays. It's microwaves. If we were to be true about it, it's every wave of electromagnetic radiation in this world. And we only actually see a very, very small sliver of it. Okay, so here's one really important thing I want you to know about light, right? We already talked about how when it goes through a prism, it gets divided into a bunch of different colors. And light has this beautiful, amazing property to it. And it's just called wave particle duality. And I don't want to get into unless you want to dive deep, I have no problem getting super nerdy, but we don't have to get that deep about this. But I want you to know that light is basically, when we talk about light, we talk about a photon. And a photon is just this little tiny packet of light, a little particle of light. So light can behave like a particle or like a bullet, right? Like a marble being shot at something. Or it can behave like a wave, like water. And it can behave like both at the same time, depending on how we observe it and how we interact with it. And that's where things get a little weird. If ever you're interested in this wave particle duality, it's a fascinating series of experiments were done. You can find a bunch of YouTube videos on it, but it's called the double slit experiment, where it shows that waves of light or a light can interact both like a wave and a particle, depending on if it's observed or not. So it's a pretty cool, crazy part of quantum physics and the quantum behavior of light. But because light can behave both like a wave and a particle, it can do different things in our bodies or in our environment. So a particle, a photon, a particle it can actually, when it interacts with us, it can actually exert a different effect when we get a direct hit with that photon versus the wave effect, where if I were to crack open my window, which I always have this window cracked open slightly right in front of me. And the reason I do that, and I get a lot of questions about this, is like, well, you're not actually in direct sunlight. No, I'm not, right? I am not actually getting the direct photons of light striking my skin. But because light can also behave like a wave, it would be the same thing as if I were in an aquarium, right? So let's just picture that if there was this basement room of mine was one aquarium that was empty, and right next to me over there was another aquarium full of water. All I would have to do to get that water to connect with me would be crack open this window, and all that water would flood into this part of the room, and I'd get all the water that was over there into me too, because water behaves like a wave. Light does the same thing. So cracking windows, it seems minuscule, right? But we have to recognize that glass blocks a lot of the important colors that our body needs on a daily basis to interact with, just for optimum health. We need all of those colors just as if we need nutrients, right? Like there's a recommended daily allowance for light. And a lot of us are sorely lacking in that. And so one way that we can do that is we can crack open windows to allow all the frequencies in to the environment. Unless you're in a really old building. So I used to own a very, very old gym. It was an old firehouse that I converted into a gym. And when I measured, you can measure the frequencies with various devices. And when I measured the frequencies of light coming through those windows, I actually got some ultraviolet light and a lot of the infrared coming through that really, really old glass. While my utility bill was astronomical there, the light was beautiful, right? It was a beautiful thing to have that really, really, the light that could transmit all of those different colors. Nowadays, most glass will block almost all of the ultraviolet spectrum and a majority of the infrared and the red as well, which means, unfortunately, that being indoors, we're becoming blue light toxic in our indoor environment, simply because we're not getting the blend of colors. We're missing out on the most important colors that balance out blue light, which would be the red and the infrared portion, which we can talk about in a little bit. So that's light, right? Let's talk about how do we interact with these photons that exhibit this beautiful wave particle duality? Huge thing, right? Circadian rhythm. I think this is foundational. And I think the coolest thing to recognize is that on our eyes and on the surface of our skin, we have things called receptors for light. I would say it was only within the past decade or so that we recognize that we've got things that are called non-visual receptors. So like research was saying, wait, why are we taking in these light? Why can we interact with these light particles when it doesn't have a visual purpose? And so certain ones, there's two specific receptors that were really, really amazing. One was called the melanopsin receptor, which actually are little receptors for blue light. And the other one is neuropsin, which is a receptor for ultraviolet light. But I want to talk about melanopsin because melanopsin is how we interact with light to set our circadian rhythm. And so you hear all the time, right? See the sunrise, see the sunrise, see the sunrise, or, go outside throughout the day, get these little light breaks, naked eyes. And that's because on the backs of the eyes, we literally have what are like little catcher's mitts. And these catcher's mitts are waiting for light to enter the eyes. One of the reasons why eyes are moist and they've got like moisture on them compared to other parts of the body is because that actually helps them assimilate more light. So they literally are like little photon sucks. So like if there's light in the environment, it's going to impact the eyes because of the moisture content. And so light then goes into the eyes and on the backs of the eyes. So not like, at the front, it'll go through the pupil, and at the back of the eye are these melanopsin receptors, which are just catcher's mitts. And these specific catcher's mitts are ones that catch blue light frequencies. And so based on the amount of blue light in my environment will determine how many of these little catcher's mitts are catching on to blue light. And because blue light is a frequency that literally changes every nanosecond from sunrise all the way till solar noon and then back to sunset, blue light gets layered on. It goes from nothing at dawn, right? And then it gets layered on. It gets really, really potent when the sun's at the high point of the day, called solar noon. And then it goes away. And as it goes away, then eventually we get nothing, right? We'll get darkness. And the backs of my eyes are super sensitive to those fluctuations. So with this presentation right now, it's only been about 12 minutes. And perhaps, me looking outside, it looks like the exact same time of day. But if I were outside for those 12 minutes, the backs of my eyes would be catching in the different amounts of photons and would recognize that actually the day is waning now, even though I wouldn't necessarily be able to consciously perceive that myself. So we sync our circadian rhythm through the eyes when the photons of light strike those little melanopsin receptors. And why is this important? Well, we're complex beings. You've heard me say this before, right? We literally have hundreds of thousands of tasks every cell needs to accomplish every second. And if this wasn't synced up in some way or coordinated through some, master control mechanism, I don't think we'd be able to become as complex as we are. And so light was a perfect input to be able to sync our tasks. The body, if we just look at it basically, the body has a certain set of tasks it wants to do during daylight hours, and then it has a set of tasks it needs to accomplish during darkness while we're sleeping. And so that's one thing about the rhythm, right? Daylight tasks, darkness tasks. And then you can translate that from these bigger tasks, right, that we see here during daylight, where the body's rhythms, where we get things like a cortisol rise, glucose becomes regulated. We have, throughout the day, we get a good immune response, high alertness. If we're going to do some sort of like coordinated exercise around 4 o'clock in the afternoon is a really good time for that, and then in the evening, we got all of this repair that happens. Digestion slows and the body goes into repair mode. We go into deep sleep, memory consolidation mode, and we just repeat it. And so that's happening. We can physically measure that at like this macroscopic scale, but we also know that at that tiny, tiny microscopic scale of our cells, this same sort of a rhythm is happening, and it's based on the light input that we're receiving through our eyes. That light then, once it's received through the eyes, it gets communicated from those little catcher's mitts to this master clock in the middle of my brain called the suprachiasmatic nucleus, which then through oscillations and vibration, which is kind of a weird thing to think about, right? It's not very chemical, at least not the initial passing of information. It oscillates. The light oscillates that suprachiasmatic nucleus, and it vibrates in a certain way that then is felt throughout the entire body, so the body can sync up what time of day it is. I almost liken it to like, church bells or whatever, right? Like you can almost feel the vibrations. It's like, that it's ding, ding, 2 o'clock in the afternoon. It's like, we almost have that same sort of a vibration that happens based on the light that comes into the eyes, connects to those receptors, and then communicates it to the brain. Here's another pathway in the eyes with light that I think is really cool and important to know. The eyes pass a significant amount of blood flow, right? I think it's something like every 40 minutes, our entire blood flow in our body passes through the eyes. So it's like there's a huge amount of blood flow. And there's a high concentration also of a specific type of amino acid called aromatic amino acids. And so this is why I'm always saying we got to get that morning light, morning sunlight, because there's a specific concentration of these aromatic amino acids. And aromatic amino acids, you'll see, they just have this beautiful ring shape right here, right? The 6-sided, sometimes a 5-sided ring shape. They're a ringed amino acid. And when a specific wavelength of light strikes that ring, it energizes it to become something else. So when ultraviolet A, photons of light, and let's talk about it, right? We get red, orange, yellow, green, blue, indigo, violet. So once the rainbow of colors has appeared from layering it on from sunrise, then ultraviolet A shows up. And ultraviolet A is more powerful. It's got more energy to it. Odd to think, but the shorter the wavelength of light, the more power is behind it. And so violet, ultraviolet, those are shorter than red and infrared. And so those shorter wavelengths of light have more energy and more power to them. And so those photons, those little particles, are energized enough that when they get sucked into the eyes and strike these specific amino acids, they catalyze them or energize them to become another chemical. And so phenylalanine and tyrosine can then become thyroid hormones, right? They can help with thyroid hormones. They can become DOPA, and DOPA then can become melanin, dopamine, adrenaline, noradrenaline, really important, both molecules or chemicals for alertness, focus, and also, things like regulation of appetite, inflammation. Tryptophan once it gets sucked or struck by that photon of light, it becomes serotonin. And then upon darkness, it gets converted into melatonin. And then histidine is another one. And histidine, when it gets struck by a photon of light, it becomes histamine. And histamine creates a pinkening in the skin. And that's called an erythema response. It's like what we associate with a sunburn, but it's just called an erythema response. But then histidine also becomes urocanic acid. It gets built up. Both of these get built up in the skin, and they give us both the signal that we've had a decent amount of sunlight. We get that pinkening. And then urocanic acid is also an endogenous, a naturally made ultraviolet filter. So it's a naturally produced sunblock, if you will. And we can learn how to maximize and really train our body so that we can absorb as much sunlight as possible without any sort of detrimental effects to it that we can hear about, which we hear about a lot with ultraviolet light. And so this is just what I wanted to go over, right? So we talked about that photon. Molecules have electrons. So what you see with the black dot, that's a nucleus of an atom, right? So that's like this nucleus. It has protons and neutrons, and then surrounding it, you've got these electrons, which are in red, and they just kind of float around, zing, zang, zing. And as soon as a certain specific, like a frequency of light, a photon of light hits it, it excites it. And an excited electron jumps out into a further orbit. So it moves further away from the nucleus. And so it absorbs a bunch of energy, and then it can drop back down to its normal ground state. And when it does that, it actually can release energy into the system. So it helps. So another thing we do is, like with all of our electrons, they capture the energy from photons in our environment and then release it into our body system. So we literally can capture energy. And this is exactly what happens, you see a lot with photosynthesis. And we never thought it happens with us, but it definitely does. And these photons then, because they spin a certain way, because they have a certain color to them, a certain wavelength, they contain both energy because they can excite our electrons, but they also contain information about our environment. They tell my body what frequencies are available in my environment. And that again helps me to sync and coordinate all of my tasks. We also have water, right? We're gonna do a whole thing on water, but you know that the photons of light interact with the water in our body, and we can actually use energy from sunlight in the water in our body. Like, so we can really create this store of potential energy in our bodies with this. We're gonna talk extensively about that. And then, I do also want to touch on the fact that there's more to this spectrum, right? This is the tiny, tiny little spectrum right here that I've been discussing. But it's also been divided into a lot of different things. And I want to talk about some of the non-native frequencies. So native frequencies are ones that are naturally produced, right? So from the sunlight, we get all these visible light colors. We get the ultraviolet light, we get the infrared. But there are non-native electromagnetic fields, microwave ovens, radars, radio waves, right? Power cables. For a while there, they said, oh, these have no potential to cause any interaction with human or any harm with any human whatsoever, because they are non-ionizing. They made this category, right? Like, so all that meant was they don't have enough energy because they're longer. And remember, longer wavelengths have less energy than shorter wavelengths. And so what they said was, not longer wavelengths do not have enough energy in order to damage DNA directly. So while you see that, yes, we know that unblocked gamma rays and cosmic rays would be an issue if we were in outer space, right? We're grateful we've got atmospheres. Those could definitely damage the DNA directly. X-rays, we know, can damage DNA directly. But these non-ionizing wavelengths, we have to make sure. Can everyone make sure they're on mute really quickly? I might have to, let me see. Let me stop my share for a second, just make sure everyone is on mute. All right, mute. Okay, there we go. Boom. Okay. All right, let's go back to it. Okay, and so for a while there, a lot of legislation was made because they said, oh, well, these wavelengths go over here, like microwave ovens and radar and power cables, because they don't directly damage the DNA. They don't have enough power to directly damage the DNA. We don't have to worry about them. And I'd like to say, no, that's not true. We're going to talk a little bit about that. But let's talk about one of these non-native electromagnetic frequencies, and that's within the visible range, right? Within visible light, we've modified it using light bulbs. And just because they're part of the visible spectrum doesn't necessarily mean they're healthy for us. So a really cool thing to look at here is daylight. So this is what it would look like at solar noon if I were to measure the light frequencies, right? It's a beautiful blend. We have the whole rainbow, a big dose though of the blue and the green, balanced though with some red and infrared, a little bit of ultraviolet. Compare that now to the fluorescent lighting. And this is the one that kind of drives me crazy because this is what we see in most offices. This is what we see in schools. This is what we see in hospitals. You see a little tiny speck of light, little tiny peaks here and there. And the purpose was to conserve energy. Having an incandescent bulb, like I did growing up in my house. Well, I mean, I still do, right? I got incandescents everywhere. But what you see here is that's high in infrared. So it's a heat generated light source. It's not as energy efficient as a fluorescent bulb. But take a look at how foreign this spectrum is. My brain, my body, my eyes, my receptors, my mitochondria don't comprehend this. So it's like a toxic lighting source. So this is why I'm very much about, turn off your lights whenever you can. Block yourself from these foreign frequencies because the body just does not know what to do with them. It can't handle it, or it's a very, very confusing message to send to the body. And also it can really do some damaging things in terms of our sleep, right? So if we look at melatonin suppression, take a look at fluorescents and LEDs, that'll suppress melatonin 80%. So having these types of light bulbs on after the sun has gone down is very, very damaging to my melatonin production. Very challenging to my circadian rhythm. Melatonin rises because my body and my brain think that it's darkness and I need to be getting ready for bed. And when I counter it by flipping on a bunch of bright LEDs or fluorescent lights, my melatonin will naturally say, oh, wait a second. What was I thinking? It's the middle of the afternoon. It's a much brighter, different spectrum. And so then we obviously know that blue light is the area that we hear is the most damaging, and is because of those melanopsin receptors. In the middle of the night, my melanopsin receptors should be sensing 0 blue light. After sunset, my melanopsin receptors should be sensing 0 blue light. So there's these they should be having these catcher's mitts literally waiting and be like, nope, no blue light, no blue light, no blue light, which then tells my body to make melatonin. But what do we have these days, right? We got every sort of screen technology we have produces blue light. And it's super, super confusing to my circadian rhythm. It's a very foreign toxic spectrum to have at night. This is now about going back to those non-native, those non-ionizing electromagnetic fields. I just want to highlight, there's a lot of areas we can have them in our house, right? And this is not an extensive course on how to mitigate them. We can talk about that, but this is not an extensive course in that. But I wanted to let you know, I find it fascinating, depending on where you are in the world. Now, this chart is a little older. But the United States and the UK set a safety standard of let's just say 1,000. We don't have to worry about the watts per centimeter square or anything like that. Basically, we allow thousands of times more electromagnetic frequency, or non-native electromagnetic fields in our environment than other parts of the world. It's just why? What are countries using to set their safety limits? Like where are the tests being done on that? And frankly, there's not a whole heck of a lot of them being done. And this is going to be one of the last things I talk about before we break for questions. What happens when we have these non-native electromagnetic fields? I want you to know how they drive inflammation. Basically, when our body, when we absorb these wavelengths of light, right? These wavelengths of light penetrate us. Now, interestingly, in the visible spectrum of light, let's go back to that rainbow of light. The violet, violet, indigo, ultraviolet, they actually can't penetrate my body too deeply. Very, very tiny. They're surface level interaction. So they interact with the receptors on the surface level of my body. Whereas the longer wavelengths of light, like the red and the infrared, they can actually penetrate through my body pretty much 10 to 30 centimeters, which is like the entirety of the body. And then the ones that are non-ionizing, that are longer, the microwaves, the cell phone radiation, they can actually penetrate all the way through my body as well. And so what happens when those frequencies are in my environment and they're interacting with my body is that my cells read it as a stressor. All of a sudden, a non-native electromagnetic frequency reaches a certain point in my environment, and my cell goes into something called the cell danger response. And that drives a bunch of calcium into the cell. And that is just the universal signal to my cell that there's danger. And then my cell starts to make some pretty damaging chemicals, one of which is called the hydroxyl radical, which it just is synonymous with like unchecked inflammation. So that's how we see a lot of these electromagnetic fields. While they don't necessarily directly damage the DNA, they can wreak havoc and create tons and tons of inflammation through the production of the hydroxyl radical and peroxynitrite and others. Okay, I'm going to stop the share for a second and let me just see, are there any questions on this? Oh, let me look through here first. The pronunciation of SCN, suprachiasmatic nucleus, suprachiasmatic nucleus. Crazy word, I don't know. I like SCN better. Go ahead, feel free to either pull yourself off of mute and ask a question, raise your hand too if you want, or you can type it in the chat. Are there any questions so far about light?
Hi, Carrie, I have a question.
Yeah, Meryl, how's it going? Nice to meet you.
Nice to meet you too. I think someone else was asking, or should I go?
No, go ahead. I'll get to that one.
Okay, great. With you mentioned the sunrise and the UVA. So when does UVA light hit? Is it right at sunrise or right after sunrise, or?
Ultraviolet A, is that the one you're talking about right there?
Yes, yes.
You know, the coolest thing is that there's two apps. Well, I'd say there's one app that tells you UVA, and that is the circadian app.
Okay.
Has anyone downloaded that one before? Let me see, my super red phone screen, right? But what you do when you go to the circadian app, there's a dashboard. So it's called Circadian. Okay. There's a link in my bio if you want to. And I just go to UVA, UVB. Like you can literally touch on the dashboard and highlight when like sunrises versus sunset. Okay. I tap UVA, UVB, and it tells me. And so that's a key time. I have found that when I time walks, I personally, Meryl, only see on a good day 5 minutes of sunrise consistently, 2 to 5 minutes, just because kids to school, packing lunches, whatever it might be. Yes. But I try to prioritize a bigger chunk of time I carve it out for like a break in my day when ultraviolet A is coming into my environment. So right now in Kalamazoo, that is at 9:25. So for example, I was outside this morning with the kids at 9. We played until 9:45. And it was like, I specifically was like, okay, I'm not going to hustle them out the door just yet. I want to wait for that chunk of time where I know it's transitioning, because there's important things that happen when that in the brain, like that addictive quality of sunlight when that ultraviolet A hits.
Wow, that's so interesting.
Good. Anything else?
Yes. So you mentioned about the non-ionizing radiation, and that travels also through electrical cables, right? That's so interesting.
Cables, and not necessarily just through cables, right? But like, remember you're a Wi-Fi router or a cell phone tower nearby, or it's crazy, a radio tower nearby.
Everywhere.
I know it's everywhere.
Yeah. So so we have a bed with a metal. It's actually an electric bed. We don't even use it. Okay. But you know, it's something we got sold into years back. So as long as it's not plugged in, is that still kind of, it's fine, right?
Yeah, you know what I mean? Like, yeah, I would say never do the electric bed, the electric blanket. Those sorts of things really emit a ton of their own radiation.
Yes.
But there are, there's ways. So I have a tri-field meter.
Okay. Yeah.
And so you can measure and see what things are like in your environment, your sleep environment. It's always good to do your own measurements. But I would say, yes, in general, the less metal you can have near your bed, near your body, like, having a mattress at some point without springs in it. Like, when we had a what's his name? Brian Hoyer. Do you know, I don't know if anyone's heard of Brian Hoyer, but he's really, really big in terms of mitigating EMFs. We had his company come in and measure, and the one mattress that they said was a really good one was like this cheapo one that was basically foam. All it is foam, but it's because it didn't have any coiled springs in it. And they were like, oh yeah, that's a great one to have because it doesn't have any of the metal springs. Right. So I mean, just be aware of where the metal is
Yes.
And where your bed is in conjunction to outlets and various things like that. I mean,
Gotcha.
do the best you can.
Yes. Yes. Got it. And then when it comes to like red light therapy, is that like best to use in the morning time or?
Yeah, morning's a great time to use it.
Okay.
Some people there's actually some interesting photobiomodulation research, which is the word that you would look at in the scientific literature for that shows that for some people, they actually get a really, really big melatonin response when they use it before bed. So you'd have to kind of play around with it. You would know within one night of using it at night if it was stimulatory and didn't help you with your melatonin. But yeah, but because red light is available, I'd say anytime's a good time for red light therapy when you're starting out, because red light's always available from basically sunrise till sunset. So you will always get a benefit from it, but some people actually do find it helps them sleep better, oddly enough.
Interesting. Okay, cool. Thank you.
Yeah, you're welcome.
Yeah.
Okay, let me just jump to this chat really quickly and then we can answer it. Prescription glasses. I have prescription glasses. They do have blue blocking in them. Is it enough? Well, that kind of depends, right, Gail? So if your screens are really orange and really red and you're not in an office environment where you're under garbage light, then yeah, that could be enough during the day. Naturally in this world, we during the day, we'd be exposed to more blue light. And so we don't necessarily have to block all of it during the day, but that would not be enough in the evening. It would not be enough if I was looking at watching TV at night, or if I was under an LED bulb, or I'm reading by an LED bulb or something. That would not be enough. There'd still be a ton of the blue light coming through. So it can have it can really suppress melatonin. The yellow ones, the more yellowy tinted ones block at about 50%. The orange ones, 98, 99%. The red ones, put those bad boys on and they'll put you to bed. They are pretty potent. And Teresa, do you have the red ones? Are those red toned ones right there? Yeah, I think those are, perfect. Those are pretty potent right there in terms of blocking all this the artificial light. So, and the red ones are great because they block the green light also, and the green spectrum can impair people's sleep too. It can suppress melatonin in sensitive individuals. Yeah, you're welcome. Any other questions here?
I have a question, Carrie.
Sure. Hi, Allison.
Hi, how are you?
Good. How are you?
Good. My question is, I live in New Zealand and there's a huge campaign against the sun here, like massive, because of the UV light here and the climate and stuff. Yeah, it's a huge battle to kind of like convince people that it's a good thing to get sunlight exposure. But my question is a mild sunburn then actually good because it's priming the body for a more healthy sun response?
Yeah, I could easily get into trouble with it. No, I don't care, right? I'll say what I think. I would say that a burn is different than a pinkening of the skin. A burn is one that it doesn't go away the next day, right? It's like when I get a pinkening of the skin, it's like, oh yeah, I'm going to step out of the sun. I'm going to go into the shade. I'm going to put a layer of clothing on, and there's no lasting inflammation as a result of it. And then then the next day I might be able to go out again and I'll get a pinkening but there's never any lasting. So no, that would not be a negative thing. That's called an erythema response. It's just an indication that you're getting adequate sun exposure, and then the uricanic acid kicks in and you're going to start to build the UV. For people in some place, right, where there's probably a more intense UV light and also probably more intense discussion against ultraviolet light. It's good to get people for sure to start with their morning light exposure because they can build their solar callus. They also want to eat enough shell. If you can get people to eat shellfish, it has that astaxanthin in it, that red pigment, which is a natural UV filter, just to make sure that their body has a built-in mechanism when they are exposed to a more intense sunlight. D-Minder app, which I know you're familiar with, is again, ding even if it's after 5 minutes to start off with. So there's a lot of ways that you can help people understand it and just slowly trickle in. Without saying go ahead and get your skin pink all the time. But
for sure.
But absolutely, I think people will see. And this is I used to be a kid who burned all the time because it was like play indoors. And then, for 2 hours, I'm just going to go outside and, and never get the morning sunlight. When we get the morning light, it conditions our skin big time, right? That
Right.
red and all that infrared and red is a conditioner for the skin to then receive the rest of the colors in a way that's way less damaging. And then in the evening, to get more of that in the evening, because that's why photobiomodulation is skin rejuvenating, because that red and infrared light then goes ahead and it helps the rejuvenation process to start while we sleep. So, I mean, there's that too. It's like a sandwich effect. That's why the morning and the evening is really beneficial too, because yes, if we do get a pinketing, we get a preconditioning and then we get a soothing.
Oh, that's awesome.
Yeah.
And also starting in spring before you head into summer.
Yeah,
right?
or even for like, right, exactly. I would say for right now, I'm super pumped because UVB is going to be present here on January 28th. So it's like, just get it, right? Start getting it when it's way less intense and the body will be able to handle it. No problem.
I know we're having like lots of questions. I have one more quick question.
Yeah, go ahead.
Might be a bit technical, but I know that there's like you mentioned, histidine with the light. So would people with a histamine intolerance, because I'm a health coach and I work with lots of people who have histamine intolerances. So would sunlight exposure help us integrate histamine in a more healthy way?
Well, absolutely, because you got to get it out of the, if you can pull it into the skin, if you can take that histidine, if you can get the right regulation. So the immune system really needs the mitochondrial, they need the mitochondrial direction. Like mitochondria, people don't realize, are really big directors of the immune system. And mitochondria then need light frequencies too to help direct it. And so that's where you get the mitochondria directing the immune system to chill out. You take the histamine and the histidine and you put it where it needs to go, right? You kind of divvy it up, if you will. So it's hard because histamine intolerance requires there are people who are really lacking typically in UV light, but they need to go super slow in terms of their ability to build it up, because they might have a stronger erythema reaction off the bat. So it's like, I really love this because one of the researchers who is potent, the sunlight doc, Alexander Wunsch, he tells this historical perspective of heliotherapy, where literally in the Swiss Alps, day 1, 5 minutes on someone's feet, pull it back in. Day 2, 5 minutes on the feet, 5 minutes on the calves, pull them back into the hospital. Day 3. So it's like, there is something to be said about slow and steady to help people assimilate it and let their body get used to it.
Cool. Thank you so much.
Yeah, you're so welcome. Good questions. Any other? Okay, let me see. Laura has a question. Let's see. UVB starts February 11th in Ottawa. Oh, yes. 7 minutes only. Yep. So there you go. D-Minder is great, right? So the D-Minder app will tell you exactly when UVB is present in your environment and when you can start making it. They even have a timer that you can use to time, how much vitamin D your body is making in response to your exposure. Other questions here?
Hi, Carrie.
Hi, Tanya. How are you?
Doing well. I have one question.
Sure.
Can you go over again when you were talking about the cells reading the non-native EMFs and that response or inflammation? Can you explain that again?
In terms of that ionizing versus non-ionizing?
Yes.
Sure. So for a while there, we never labeled the non-ionizing spectrum as damaging because it's longer wavelengths and they can't damage DNA directly. So that's why that's why you tell someone you never want to get 100 x-rays a year, right? Like because excessive x-rays will directly damage the DNA and cause DNA mutations. And that we know then can lead to cancer. I got a different perspective on cancer too, but that's what the logic is with that, because of how potent those shorter wavelengths are. Ultraviolet light falls into that, x-rays fall into that. They directly damage the DNA. That means they're cancer causing. Avoid them or minimize them. They didn't touch the longer wavelengths of light because they don't have enough energy. Like those photons of light don't have enough energy behind them to directly damage DNA. So we thought, because they can't directly damage the DNA, they must not have any detriment to human health. But the researcher's name is Martin Pall. I believe he's out of the University of Washington, maybe Washington State for him. He's done decades of research that shows that when our cells are exposed to a certain threshold of those non-ionizing ones, you get that calcium flux into the cell and it creates this massive cell danger response, which can really result in uncontrolled inflammation.
Perfect. Thank you so much.
You're welcome. Okay, let's see. Question here. How can we support our body when we are in artificial light all day long? If I'm in an office environment, or like even when I go to the grocery store, right? I would wear yellow tone glasses, typically a hat on, and you want to cover up. In artificial light, you want to cover up. So it's like I have longer sweaters, and it's like, you want to wear, that's where you want to wear your scarf around your thyroid gland, because the thyroid is very, very close to the surface of the skin. So that blue light will penetrate and it can disrupt thyroid function. So in an office environment, I am covered, and I'm drinking a ton of spring water because it's a super, super dehydrating one. I don't have it here because I think one of my kids stole it, but I sometimes have my grounding mat underneath me if I'm doing a lot of office work too. That I way prefer grounding outside, but looking at Clint Ober's research and a couple other people, they really show that you can give yourself almost like a little protective shield if you ground yourself, so that those non-native electromagnetic fields don't get trapped, if you will. They kind of just push themselves through you. I'm still wrapping my brain around that one. But yeah, I would say cover yourself up and then take potent light breaks throughout the day. Go outside, sky gaze, go like this, look up at the sky, not directly at the sun, but like suck those photons in, tell that SCN what time of day it is, and then go back inside and continue your work. Anything else? Maybe one more question before we move on here. Is the cell danger response due to emotional trauma or other stressors also triggering? It's both actually. So the cell danger response can be from an infection. It can be from, so like, let's say mold or Lyme or something along those lines. The cell danger response can definitely be from an emotional trauma. And then we also know then that electromagnetic fields, these non-native electromagnetic fields, can also trigger it. So it's like, I mean, that's a lot of us these days, right? Well, a lot of us have some sort of a chronic infection. We're working indoors, or we're surrounded by these non-native electromagnetic fields, and we're going through some sort of an emotional stress. That's really easy to see how this unchecked inflammation can just continue and continue. All right, I am going to move on to the next one, which is water. Hydration at the quantum scale. Woo, woo. I love this topic. The real role, right, that water plays inside of our bodies. Okay, so there are 4 phases of water. So back in grade school, right, it was liquid water, and it was water vapor, and it was ice solid, right? So liquid, solid, and gas. And now we know that water exists in a 4th phase. And believe it or not, it actually exists in a 4th phase in a glass too, when it looks like a liquid to us. Kind of wild to think, but it really actually exists in that 4th phase when it's inside of our bodies. And so it's going to be fun to talk about that. So we kind of have to reframe our brain, right? There's a traditional view of water that it comes in just 3 phases. And now we know that inside of us, it is in this special 4th phase. Looking back at my college education, I loved studying biology, but all we were ever taught was like, oh yeah, the water is just there. Or it's like the liquid, it's like this aqueous solution where all the important biochemical reactions take place, but it really doesn't do much. But now what we know at the quantum perspective is that it's foundational. Water is foundational, both in being a storage form of energy for the body, and also a conduit through which communication can happen. Traditionally, hydrate, just drink lots of water. But if we're looking at it in a quantum perspective, hydration involves building this 4th phase of water, having adequate minerals, moving, and then mending all the super highway, our connective tissue, where all of this quantum water really forms and then flows. Here's what it looks like, right? This is a picture out of the 4th phase of water. It's Jerry Pollack's book. He's the one who really popularized this 4th phase of water that's inside of us. And what you'll see here is you will see that this quote unquote material, just picture that as any biological surface. It's your cell membrane. It's a protein inside of you. It's a part of a mitochondria. It's your nucleus. It's your DNA. Any biological material will form this special water next to it called EZ water. And you'll see it's structured. It forms up like a honeycomb shape, which looks a lot like what ice would look like under a microscope if we were to blow up the structure of ice. when we look at water in a glass, it's just the molecules are kind of sloshing back and forth. They're not rigid, they're not structured. So this is where you get this concept of exclusion zone water, right? This easy water. And this is why I call it a liquid crystal, because it's still in a liquid shape format. It still has flow to it. It's not rigid like ice, but it's definitely structured like a crystal, or like how it would look like to look at a diamond at the molecular scale, to see how everything is arranged in a very ordered pattern. So cool that this happens inside of us. It's called exclusion zone water. So just told you it forms next to all biological surfaces, almost all. It has a negative charge. So you hear me harping a lot on negative charge, negative charge, negative charge. It's not, this is not a controversial statement, right? That a cell needs a negative charge for health. The human body needs a negative charge for health, right? That's something that I learned, a long time ago, going through undergrad, graduate school. It's like, yeah, we need a net negative charge. But I was taught it happens through this ion pumps in, this one pumps out, pumps in, pumps out. So you pump the positive ones out, you pump the negative ones in, blah, blah, blah. That's how the cells maintain their charge. I think it's a little bit easier than that, actually. I think that this easy water, when it's adequate, when we build it up enough, we create this beautiful negative charge inside of our cells. This exclusion zone water semiconducts electrons. All I want you to think about that is literally within its structure, wherever it's formed, it can pass electrons throughout it. And it also can kind of allow photons. It can trap photons. It creates quasi-free electrons when UV light hits it. So UV light, and this is another weird thing to think of. UV light, yes, comes from the sun. When sunlight strikes us, our exclusion zone water, it can like eject electrons or create this beautiful quasi-free electron state. So basically that's just electrons, more electrons for the body. But we also make our own photons of light. And I didn't do a detailed slide on this, but our body makes biophotons in the ultraviolet spectrum. So we make ultraviolet photons that then can also interact with this exclusion zone water to create these free electrons for us. It traps electromagnetic fields. Everything you saw on that electromagnetic radiation spectrum, right? All of those are electromagnetic fields, from the cell phone radiation to the ultraviolet light to the infrared to the cosmic rays, anything that can get through the planet, right? And can be by us, we can trap those electromagnetic fields in our exclusion zone water. And we trap them for a couple of things. Sometimes they provide energy for us. So like if we were to trap some ultraviolet light, right, then that ultraviolet light would create these electrons for us as energy. Or we can trap, we can unfortunately trap a Wi-Fi radiation, and we know that actually decreases the exclusion zone water. So we can trap them all, and our body uses those trapped EMFs either for energy or information or both. And immediately next to this, so wherever this forms, they're ultimately, because this is negatively charged, it becomes negatively charged because it kicks out a proton. It kicks out a hydrogen ion. So it just becomes basically, it kicks out a proton. And so right next to it, you get this negative charge, you get this buildup of protons. It forms a proton wire. And that's a battery, right? That's a battery. And that battery is basically a battery of potential energy all throughout the body, inside of every cell, that we can use to do work. So we can do things that make this easy water bigger. This is another image out of Pollock's book. Here is what this black line image is, what you would mimic a biological surface. It's just called Naphion in a lab, but it's a biological surface. And then you see easy water. Why is it called easy? It's called exclusion zone water because it excludes things from it. And so what you see in this other part of the water, the non-easy water that we refer to as bulk water, just regular, that's regular sloshy water in a glass, non-structured water. What they put into that water in a lab is they put in these little tiny dots called microspheres. So it's just basically a bunch of little tiny beads, micro beads in the water. And what they showed is that, yes, when you put this micro beaded water, you mix up a whole bunch of micro beads in this water, and you throw it into a petri dish next to a biological surface, and naturally an exclusion zone will form. So this naturally happens. It'll exclude out anything that's bigger than the size of a proton. So it's kicking out protons, and as it's kicking out protons and building that honeycomb structure, it literally is kicking everything else out too. And that's happening everywhere in the body. But the coolest part is that we can make it bigger. They found that you can make it 4-fold bigger or even more when you expose it to various things. And so you see that exclusion zone grow, 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 grow. And so that's those layers of structure, that honeycomb structure building up more and more and more, kicking out more and more protons and pushing everything else further and further away from the biological surface. So we can make a bigger exclusion zone. If we're making a bigger negative charge, we're making a bigger concentration of positive charge, and that's a bigger battery. That's more potential energy for the body. We're making a bigger negative charge, which is what we run on, right? So like I said, we need a negative charge. And so when we build exclusion zone, we build that negative charge for the body. And this exclusion zone water, it's a different phase because it's more of like a gel, right? It does have more of a structure to it. And so it helps our body hold all of our proteins and our mitochondria. Everything in our body needs to be held in the right configuration for optimum function. And that exclusion zone water helps hold things in the right shape, the right form. And then this also then allows, because it can trap electromagnetic fields, because we can trap photons of light, this allows for better communication at the quantum scale. Here's another way of looking at it. I just really like this image, and sorry it's so blurry, but what you see here is you see that gray is the biological surface. In it, you see that there are something that you can do called you can put a micro electrode, which is just like a little, almost like a little plug, right? So you can put a little electrode into the negatively charged EZ, which you see in blue, and in the positively charged proton zone, which you see in the reddish orange color. And they've done that in the lab, and they've actually powered a light bulb with it. And so that just shows we literally have potential energy. We have energy flow that happens simply from this exclusion zone formation. And that's why I did this post, right? There are ways that the body gets energy besides food. Some of it touches on the exclusion zone water. Some of it touches on a couple of other things like the piezoelectric effect of movement. But that being said, it's a misnomer. It's kind of old school to say that the only way in which we get energy is from food. That has now been debunked, disproven, not true at all. And so I think it's important to recognize that light and how it interacts with its exclusion zone water is one way we can do that. And that's because this exclusion zone water, the biggest expansion we see happen in that exclusion zone water when it went from that small little chunk to a much bigger one was when it was exposed to infrared light. So that could be infrared light from the sun, that could be infrared heat from a fire. We'll talk about other ways in which we can make a bigger infrared inside, or bigger exclusion zone water, or better our exclusion zone water in our bodies. But it's just, I think, really important to know that we're meant to interact with light. We're meant to interact with grounding. Grounding, believe it or not, also builds exclusion zone water. So all of these things that I like to recommend, it's almost like they do a lot of things for us, right? Grounding and being outside at sunrise, we set our circadian rhythm, we're sucking electrons into the body, because that morning light is full of infrared, even in the winter when it doesn't feel warm, it's full of infrared. And so we're building the exclusion zone water in our bodies. So we're making a bigger battery to start the day. So there's a lot of ways we have to recognize that our body can get energy, and it doesn't always rely on electrons from food. Body-wide communication. This is another one that I think is a misnomer, right? We think about, nerve impulses, our nervous system really fast. Well, nerve impulses travel about 150 miles per hour. But the electrical messages that happen through fascia, through the collagen network, through this total body communication network that I call it, right? This quantum superhighway of fascia, that can happen at 750 miles an hour or faster. It can sometimes happen instantaneously in certain spaces. So while I do think nerve impulse travel and communication is important in the body, I think that the body-wide communication that makes the most sense in terms of how we need to pass messages super fast to coordinate, hey, what's happening here to what's happening here, is through the fascia and through the connective tissue. And it all is surrounded by exclusion zone water. So I think the exclusion zone water is this beautiful conduit through which we pass energy in the form of quantum particles, from electrons to protons to photons to vibrations. And all that can get communicated through this body-wide fascial network that's surrounded by easy water. So this is fascia, right? This is fascia. This is, I hate to say this, but like, you know, people say when you cut a chicken breast and you kind of peel that thin translucent skin portion, that's part of the fascia. But fascia literally penetrates down into everything. And so when you think about, we'll talk about, right? So it literally, you have all of these lines of that penetrate. So here you have all these things are basically the same, right? The blue little wiggly lines, the pink wormy things, all of these things, even what you see inside here, these little gray zigzags, what you see is a cell membrane. This in the bluish area is the extracellular space, the outside of the cell. This is the inside of the cell, but it's all connected. They've got proteins that literally connect the inside of the cell with the outside of the cell. And these are all just different forms of fascia or different forms of connective tissue. And this, if we were to take a look inside the cell, we would see that these zigzag lines will basically crowd the space inside of the cell, go all the way into the nucleus, which is another membrane, through that membrane, and touch every piece of DNA. So we are all connected 100% through this connective tissue network that can be called fascia, it can be called collagen, it can be called the extracellular matrix, depending on where it is. It drives me crazy that we've compartmentalized the human body into like locations as opposed to recognizing the totality of it. But all doesn't matter. What you need to know is that this body-wide communication network is covered by water. And when this water, it's exclusion zone water, because these are biological surfaces. And when this water shrinks down to very, very small spaces, it's called nanospaces. So for example, when it shrinks down into the tiniest little collagen folds, or when it's found in between the helix of DNA. So DNA is a winding double helix, the water in the interacts with the DNA. All of it then exhibits some really special quantum properties. One of them is called superconduction. Another one is superfluidity. And all I want you to know about that is it means literally that communication can happen instantaneously at the speed of light without resistance. It flows. So water in nanospace, it's the nanospace water that is truly this connection that coordinates everything that's happening in the body. And it's all connected via the connective tissue network. Okay, so here's what you probably most want to know is how do we maximize this easy water? Like, what are things that we can do? Well, you know, we can drink some really good quality water. One thing I want to note is we want to filter our water. The way we're given water these days, where we force it, you know, through pipes and force it, it's like, it's, you know, it's cleaned with toxins. I mean, I'll call them toxins, right? Chlorine and fluoride and things. There are things in our water supply that are just not necessarily meant for regular human consumption. And so we want to filter our water for sure. If we at all have access to things like natural mineral water, natural spring water, a water that's come from nature, there's this beautiful process of how water gets to us in nature. It's a whole cycle. And once it's available for us from a drinking source, it's been vortexed through so many different ways. It's been passed through the electromagnetic fields of the earth. It's absorbed radiant energy from sunlight. Like it drags in the natural minerals from our environment. So it's this beautiful water that really does promote health. We can kind of try to mimic that. There are certain devices that will vortex our water. They will structure our water. They are gaining so much more merit the more I'm diving into this research, and then also hearing other anecdotal stories about how they've been beneficial in terms of health. And so just buyer beware on that. But there are ways that we can structure our water that we drink in order to make it more energetic for our body, to have more exclusion zone water in it, and also then therefore be more beneficial for us overall. Excuse me. So we can drink good quality water. And if the more indoors we are, the more we're going to want to consume really good quality natural mineral spring water. There are things that destroy our exclusion zone. This is not, or destroy our collagen network, that connective tissue network. This is not an exhaustive list, but these are a lot of ones that will do it, right? Glyphosate and pesticides, fluoride. Fluoride, if it's in, I'm really big on it because it's in my municipal water system. It will lower our water's ability to store energy. So like I said, we can make this big battery, right, full of potential energy. If there's excessive fluoride, then it lowers, it's called the dielectric constant. It lowers our water's ability to hold on to energy for us. Heavy metals will disrupt it. Non-native electromagnetic field devices, so cell phones, please, if you have a laptop, like the goal of these things is to use them as far away from your body as possible, because they will destroy the exclusion zone. They'll start to slowly chip away at it. 20% I've seen in some studies, 15%, but that's a significant amount to drain your battery. If you think about it, especially if we're doing it all day long. So trying to minimize our exposure to those sorts of things. Another one is anesthesia. I didn't mention it here, but general anesthesia, one of the reasons why I think some people react so negatively to it is because it definitely diminishes exclusion zone water. These are things that were done in research that will build exclusion zone water. They will build exclusion zone. Chia seeds are another one that I forgot to add on to this, but and these are when they're consumed in what are called natural quantities. So this isn't necessarily turmeric supplementation. This is like turmeric from food, how we would use that to create a curry or something like that for our food. When these were studied, there's definitely a curve, right? That there is, when we don't consume them at all, there's no benefit to our exclusion zone. When we consume them in a natural amount, there's a benefit to exclusion zone water. And then when we consume them in an excessive amount, there's no benefit. So all of these things are consumed in we want to consume in natural quantities. More is not better. Contrary to how I think a lot of us operate in this world, more. When it comes to exclusion zone builders, consuming these just in natural amounts is beneficial, not too many. We want to we can do things that expand that EZ. So as I mentioned, infrared heat, infrared light, they're synonymous, right? But they will expand that EZ. So where do we get infrared? Well, sunlight is full. 42% of sunlight's infrared. Sauna is infrared. I think there's a reason why a lot of let's say northern cultures, northern latitude cultures in the middle of winter have a tradition of using sauna therapy, because I think that we recognize that besides that heat feeling really good in the middle of winter, we actually are getting energized from it. We're building our exclusion zone water from heat therapy. Cuddling, human touch, touching a pet, right? Having a cat sit on your lap. Anytime we actually can feel infrared and we have that infrared exchange happening, we are getting a benefit for our exclusion zone water. When we make our own infrared via exercise, we're expanding our exclusion zone water. So exercise, I think one of the main benefits to exercise and generating body heat is building exclusion zone water. Again, that full spectrum light, we get not only infrared light, but we get the UV, and that UV the UV energizes that exclusion zone water. So we build that big battery, we expand our EZ fourfold, and then we get those free electrons from the UV. But we have also infrared panels. Those are good. Cold exposure. Cold exposure, actually, our mitochondria, when we're cold, our mitochondria make more heat for us. And so those mitochondria then make more heat inside of our cells, and that heat will structure our water into exclusion zone water. And then earthing and grounding, we know will build a bigger exclusion zone. And then we also want to surround ourselves with healing electromagnetic fields, such as the Earth's electromagnetic field, or what is from sunlight, not necessarily the Wi-Fi and the radiation and things like that, but also positive emotions, love, gratitude, anything that creates a beneficial heart rate variability, it's called. So basically any positive intention, it helps to structure that water inside of our bodies into a more coherent crystal. And so positive emotions, surrounding yourself with positive people, very, very beneficial for this. All right, I'll stop the share, see if there's any questions here. All right, let me start here really quickly, because let me see if we have any. Oh, okay. Ways to structure water. How can we make more biofluid? Oh, great questions. All right, so I'll start here. How about that? Let's see. Okay, so did I say that spring water is dehydrating? Oh, no. I should not have said that. It's very hydrating. So yeah, drink plenty of spring water. Excuse me. It's very, very hydrating for us. Coconut water. Oh, coconut water is interesting, right? It's the only issue with coconut water. So this is a good anecdote for that. Glucose, sugar, also builds an exclusion zone around it, a big exclusion zone. So that's why our body tries to regulate its blood sugar to have only so much glucose in it, because when we have too much, it actually, we don't want sludgy or gelled blood, right? Blood is an area that we want to flow. And so coconut water is okay for people. Some people tolerate it very well. Some people tolerate more carbohydrates very well, especially if it's seasonally. So moderate amounts of coconut water actually have been shown to create a big exclusion zone, but it has to be in the context of what's happening with the rest of my blood glucose, because I don't want sludgy blood, for lack of a more scientific term. My thoughts on molecular hydrogen. Oh, through electrolysis. You know what? I've never used electrolysis for molecular hydrogen. I've used the tablets. I do feel like for the most of the hydrolysis machines that I've seen, they only generate so many parts per million. I want to say like 2 to 3 parts per million. Maybe you have a machine that does more. In a lot of the tablets that I've seen for the molecular hydrogen, you can get 10 parts per million in a glass. And so the benefit to me comes from the ease with which you can dissolve a tablet and know that you get a good quality in terms of parts per million of the molecular hydrogen. Let me know if you have any follow-ups on that one. What about simply shaking spring water? Would that increase ET? Yeah, it would. That's a great, so here's the deal, right? There's, I don't know if anyone has ever seen how homeopathy is made, but what happens with homeopathy is like you put, let's say I were to put a healing substance, right, in water, and I would put like 3 drops of it, right? And then I have to shake it up at least 100 times. And then I dilute it, right? So I put just a little bit of that and I mix more water with it. And then I shake it up, and I dilute it. And so I dilute. Shaking water actually helps the water build structure. And so, yes, I think that if you've ever, I made my own, carbonated water out of my structured water here. So I don't want to shake my carbonated water. But that being said, you can definitely shake it, and you'll see what happens when you shake it. You'll see a vortex forms. And so, yes, I think the effect of shaking water like that is it's not lasting. I don't think you're going to have something that you can shake and then all of a sudden 3 weeks from now, it still has its structure. But do I think, and this sounds so crazy woo, but do I think you can really shake up your water and then have a loving intention or a healing intention in your water and then consume it and have it have a benefit? Absolutely, 100%, I believe you can. Do I like IR infrared heaters? I guess it depends on the type of heater. Any form of infrared, Laura, will build exclusion zone water. You have to balance infrared with non-native electromagnetic fields. So that's where something like, I'm not a fan of an electric blanket, because yes, would that infrared possibly build some exclusion zone water? Yes, but do we also know that the non-native electromagnetic fields have the potential to destroy it too? Yes, so I would say it kind of depends on the type of the heater. How can we make more biophotons? Oh, good question. So like, you want to make the right amount of biophotons. It's not, the body uses biophotons as a signaling mechanism. And so you want biophoton production to be adequate. So for example, mitochondria make biophotons naturally through the process of cellular respiration. When they make enough, you lose a couple. So you make biophotons when you lose electrons, right? And so that's kind of where it's weird too, right? You lose electrons, too many electrons, that's reactive oxygen species, that's damaging. So you don't necessarily want to make more biophotons in that sense. You want it to be just adequate. So we want to leak a little bit of electrons to kind of tell the body what's happening, but too much would cause too much damage. Though when you do it, when we're not looking at it from inside of the body, when we're looking at it, let's say from a measurement outside of the body, we in states of meditation, actually, we can measure biophoton release. So there's been really interesting studies done when people have been meditating and sending intention to someone or something on the other side of the world. We see that when people are in a meditative state and they're sending intention, they actually are releasing more biophotons of light from the palms of their hand. I think that also probably happens during massage and things, and just healing touch or energetic touch like that. And so in that sense, it's the intention that helps us to have the healing biophotons coming from the hands. Good question. Let me know if there's any follow-ups on that. Okay, Cindy, ways to structure our water. Minerals make a huge difference. So I would say that's step one. Make sure your water is as pure as you can make it. So filter it as best as you can. And then minerals add structure. minerals form exclusion zones around them. And so when we have naturally occurring minerals in our water, they naturally have more exclusion zone water in them. So naturally have more structure to it. So let's say I then have my water mineralized, you can vortex it in some way. Now, I'm playing around with a couple of different things. I had a couple companies send me water, really interesting water. So there are certain quantum hydration processes that people have used to show that they can make structured water and have it stabilized for a long time. I would say if I just wanted to do it as quickly as possible, it would be one of those things where I would have pure water, make sure it's as purified as possible, add some trace minerals to it. So like a trace mineral blend that could be humic minerals, fulvic minerals, quinton minerals, trace minerals. I know someone I think mentioned ion biome they've used before, like ionic minerals. All those things are beautiful. So those are great minerals, and then give it a good shake or put it into some natural light, set it in a glass jar, put it in some natural light to absorb some of the earth's frequencies, and then shake it up with love and drink it. That's a beautiful way to structure it. Am I a fan of Kangen machines? I have not looked into that particular company. I've actually avoided a couple of requests to chat with people about Kangen, and there was one other water structuring one. I forget. So I don't know much about them. Maybe I should just have a nice conversation to see. And so is that what I mean by becoming a fan of? Oh, actually, no, actually. So there's our specific machines that can vortex your water for you. And they're called water structuring machines. One of them is the Duet Water Revitalizer. I just got one per recommendation from a client, and I've actually been playing around with it and really, really like it. This particular client has used it with benefit for her pet, for family members and things like that. So and it's one that has some really great. I feel like it was made in conjunction with the people who wrote Dancing with Water. That's a beautiful book that was written a while ago about structured water in nature. A really, really good read. And has been shown then to enhance things like having a higher structured water content in it. It has a higher, or it has a negative charge to it. So like things have been measured for it. And it actually then there's been studies that show when people drink these waters that have been vortexed in machines, that it improves various health parameters. So it's lowered blood lipids, it's improved blood glucose profiles in diabetics. It's increased heart rate variability, which is a measure of our autonomic nervous system. So how stressed out are we versus how calm are we and able then to respond to stress appropriately. So that's what I mean. It's these. So that's one, the Duet Water Revitalizer. And then the other one is called the Vitalizer Plus, I believe, Vitalizer Plus, that I've researched. Both of those are good. And then like I said, there are some companies that are making bottled structured water with 30 years of research behind them. Very fascinating, that I'm diving into. I hate backing though brands and stuff like that, unless I'm really, really 100% on board with it. So those are my water vortexer recommendations. The one that I got was the Duet that I really liked, the Duet Water Revitalizer. Wood-fired sauna. Does a wood-fired sauna also act as an easy expander? Absolutely. Yep, because that heat, anytime you are experiencing heat, you're experiencing infrared. Infrared heat and infrared light are the same thing. What water filter do I recommend? I recommend, so the Wellness Enterprise is a small little company that makes the most amazing water pitcher. So if you're just a pitcher person, it gets rid of so much stuff while keeping good stuff in it. Back in the day when I started all this, I had that pitcher. It filtered out the fluoride, the chlorine, all the garbage from my water, and then I would add remineralizing drops to it. I use trace minerals from Upgraded Formulas. That's the minerals I use. And so that's a great brand. Berkey is another really good brand. Berkey does a really good filtration system. Greenfield Water Systems is one that I've had clients use. Oh, hey, I just wrote an article for livevitae.com. I don't know if anyone knows Ryan from Live Vitae, but I just wrote a water article for his website, livevitae.com, and I give all of my brand recommendations there too. So I can link that when I send out the recording for this, I can link that and give you some more ideas. Does salt and electrolytes help structure water? Yes, especially if we're looking at a blend of salt, Allison. So that would be like like I said, like the trace minerals or something like a Celtic sea salt or anything that adds electrolytes to your water will help create structure because all minerals form exclusion zones around them. How to use quinton minerals. Well, you know, my favorite way for quinton minerals is actually to get them in the ampules. Meryl, if you're familiar with that, get them in the ampules. And actually, I like the hypertonic one as opposed to the isotonic at first. And I break off one, you break off one glass end, put it in your mouth, break off the other glass end. It literally vortexes a bunch of minerals into your mouth that tastes like salt water. Swish it around and hold it in your mouth for about 60 seconds and then swallow it. I think it is, I think they have some really good merit to them, those quinton minerals. I was thinking of using my Juve to charge my water. You know, I've been seeing people do that. They're using red light devices. I don't think that's a bad thing because water has a memory, right? And so anything we do to try to improve our water with loving intention, I know anything we do to help improve it, I think matters because water can hold on to a signature, can hold on to a vibration, a frequency, a thought. Our thoughts and our intentions are our own electromagnetic fields. They actually have waves, right? We can measure our brain waves. We can measure our heart's electromagnetic field. And so anything we do that helps to put intention into our water will be of benefit for it. All right. Any other questions here? Move on to mitochondria. All right, let's do it. If anyone needs to leave at 2:30, I totally get it. I think we're going to be going a little bit over, but don't worry, you'll get the full recording. I'll stick around here and go through all this fun stuff. Hey, mitochondria. Woo, woo. Okay. This was I did a certification course. I taught a certification course for the Quantum Biology Collective, and a couple of these slides are from that. I really like this image because where do mitochondria come from? Well, mitochondria, they are these little tiny structures inside of all of our cells that take electrons and they make electrons into water and ATP. But they were just once bacteria themselves. They once were just their own little their own little, separate bacteria that were living outside in a very harsh environment, right? Which is probably more like the deep ocean vents, right? Or like where there was, it was not as hospitable, right? Life was not as hospitable. So we're talking a long, long time ago. And what happened to create these bacteria, these little bacteria that were doing their own thing? How did they become part of us? Well, the story goes that in a very inhospitable Earth back in the day, that you had these little mitochondrial bacteria, and they were able to take oxygen, the little oxygen that was there, the less oxygen that was there, they were able to take that oxygen and they were able to make energy from it. And so these little bacteria said, oh, look, I'm really good at doing this. And so one day they bumped into this other bacterium, let's call it this blue bacterium right here, this big blue blob, another bacteria from ancient Earth. And this blue bacterium said, wow, you're really good at making energy from the little oxygen that's there. I'm not so good at doing that. I'm really, really bad actually at making energy, but man, my outer shell is super strong because these harsh conditions don't bother me whatsoever. I got a really strong outer shell. And well, this little oxygen breathing bacterium, this mitochondria said, well, I'm super good at making this energy, but I get killed so easily because these conditions are brutal. These are rough conditions. And so what you have is something called like basically the endosymbiont theory, this idea that this really strong protective bacteria engulfed or sucked into it, like literally swallowed and held the oxygen breathing bacterium. And the conversation went something like this: thanks for protecting me. You don't worry about the energy production. I'll make all the energy for us. You just do the protecting and we can go on and have this beautiful partnership. And so that's kind of what happened, right? We have these ancient remnants of bacteria inside of us. And because they were bacteria, they had their own ability to sense everything in their environment and respond. And it's still what they're doing inside of us, right? They can sense electromagnetic fields from the visible light spectrum to the non-native ones. They can sense the amount of oxygen. They can sense time of day, like circadian rhythm. They can sense all these things because they once had to do it on their own. And they still have their own DNA, their own gene, their own genetic code that they brought with them as well. And so then you eventually have them literally in an egg cell, you could have 1 million of these, right? You have a ton of them in your brain, your heart, your immune system, your muscles, right? So our body concentrates these mitochondria in very energy, in tissues that need a ton of energy, but every single cell has it except for red blood cells. And so a lot of people talk a lot about fuel these days, right? Like, how are we fueling our bodies? What types of foods are we giving it? And I say, what matters more to a car? Is it the fuel at first, or is it the engine? Picture a car, picture a Ferrari, right? It's this beautiful Ferrari, beautiful car with a broken engine. Doesn't matter if I put in premium gasoline, doesn't matter if I put in unleaded, it doesn't matter if I put in the worst sludgy gasoline I could possibly find. The car is not going to go anywhere if the engine is broken. Now picture this beautiful Ferrari that has a pristine engine. Maybe it needs to maybe it really, the owner's manual says only give it premium unleaded, only give it the top of the line fuel, right? Give it the best fuel you could possibly find. But if I give it a lower grade fuel, is it still going to run? Absolutely it is, because the engine is strong enough to be able to handle a lower grade fuel. And so the mitochondria are like little engines inside of us. They need to be strong. And when they're strong, based on a lot of things that we're talking about here, and from circadian rhythm to that exclusion zone water, all those things that benefit exclusion zone water, when those mitochondria are strong, we can get away with a bit of a lesser fuel, and the mitochondria can handle it. But when our engines are broken, then we absolutely must be giving it the best fuel possible. And so let's talk about what that kind of looks like here with mitochondrial health. And here's some paradigm shifts we want to do, right? This current idea is that mitochondria are important because they make ATP. I was taught in college and graduate school that ATP is a high energy molecule in the body. It's an adenosine with 3 phosphates, right? Adenosine triphosphate. And supposedly one of those phosphate groups in between, there's a high energy bond. And when that phosphate breaks away, it releases energy. And that energy is used by my system to fuel everything, like to power up. It's where I get the energy in my body from. I don't believe that, actually. There's a lot of equations that were done 50 years ago by some brilliant people where they showed, no, actually, that's not a high energy phosphate group. And no, actually, that's not the role of ATP. And literally it's gone 50 years and no one's questioned it, because for so long, when we get stuck in a paradigm, right? When we get stuck in this idea that, yeah, of course, ATP is the energy currency of the body. Of course it is. And when we question it, it's like, oh, it's easy to say, no, that person has no idea what they're talking about. Even though no one has questioned the fact that everyone was in agreement that, yeah, what this person is saying makes sense, but it doesn't fit into what we've been taught and what we want to consider. So the current paradigm is that ATP and mitochondria make ATP, and ATP is energy. I disagree with that. I think actually mitochondria are important because they make that water, like I talked about, that special water that literally can store energy for us and does so many other things. They also make ATP, and we can talk about that at a different time. So yes, mitochondria do make ATP, but that's not the reason why they're that important. Current paradigm, mitochondria are the powerhouses of the cell because they make ATP, and ATP is energy. No, mitochondria are actually both the engine of the cell and the battery of the cell. They're the battery of the cell because they make that water that helps to store quantum energy and quantum information, right? They make water for us. We take that water, we structure it into exclusion zone water. That exclusion zone water is potential energy. And then they're the engine of the cell because they take electrons and they make those electrons into the water, right? And so there's these beautiful machines for us. And so they make the water and they also make the ATP. All you need to know is that mitochondria make ATP. No, that's not true. That's not true. Actually, mitochondria, because they used to be bacteria, they can emit and receive their own electromagnetic frequencies from both the internal environment of the cell, from the external environment outside of our body. They're very, very sensitive to electromagnetic fields, electromagnetic frequencies. Go back to that picture on slide 1. All of those things you see are electromagnetic frequencies. And they're very sensitive to the ones that are both inside of us that we're making, such as our thoughts, our emotions, but also then the ones that we surround ourselves with in our external environment. And then the current paradigm is that like genetics and DNA are the most important factor in modern diseases. That's why when the Human Genome Project was completed, we thought, oh yeah, we'll be able to really make genetic specific, take a look at someone's genes and really make specific medications and cures based on their genes. And I would say, yeah, we have DNA and genes are important, but I think our mitochondrial health is the most important factor in modern disease. And the researcher that really has hit this home is Dr. Doug Wallace out of the Children's Hospital of Philadelphia, who has shown that basically 80% of our modern diseases are mitochondrial in action. You can see literally changes in the mitochondria in conjunction to with how diseases progress with zero changes to the genome or to the genetic expression of certain genes. So conventional in mitochondria, eat food, it becomes electrons. These electrons go into this electron transport chain that I talk so much about. You make ATP, oh, and then yeah, water and carbon dioxide are byproducts. And this happens here. Here's a snapshot of a little tiny mitochondria here. And inside of the mitochondria, you have all of these electron transport chains, which are basically just, I want you to think of it almost as like stepping stones or like a conveyor machine, right? Where you see this solid line here with the arrow. This is just the flow of where electrons go. And an E negative that you see here, that's an electron, an electrically charged, negatively charged, right? They're electrons and they just flow. And these things, because electrons are flowing through steps 1, 2, 3, and 4 with a couple of helpers, these electrons want to flow because they need to flow all the way through the 4th step. And that's because that's where water is made. And as they flow, you get the buildup of protons in this intermembrane space. And that buildup of protons drives ATP production. So you have this beautifully coupled system, a really nice system happening. But this electron flow matters. And when we lose electrons from here, we create free radicals, that reactive oxygen species, and that's damaging. And so we don't want to lose electrons from this. If we lose electrons, we're not making water, we're not making ATP. And so how do we lose electrons? Well, the distance that each of these steps is, steps 1 through 4, the distance between them matters. In the quantum world, electrons like to do something called tunneling or jumping, right? They like to tunnel or jump only so far. So if these steps are spaced only this perfect distance apart, the electron would love it. The electron says, oh, that's easy. I can jump, 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 and then make this process where I make water on this final step. But when these steps are spread out too far, the electron says, I'm not going to jump that far. I can't do that. That's way too far. And we start to lose electrons from the process. So I like to give this analogy, picture a stream, right? You have 5 steps, let's say 5 steps to get across that stream. So 5 different rocks spaced throughout the stream. Well, if it were me and I had to get to the end of the stream to create, for success, to the other side of the stream, let's say that stream is 10 feet apart. Well, yeah, I can for sure space the rocks every 2 feet or so and jump, 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 and I'll easily make it across. So that would be an electron saying, yeah, that's no problem. I can bounce, 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 no problem. But now all of a sudden, let's say that my river that I have to get across is 100 feet. And now I have to space these rocks every 20 feet. I'm not jumping 20 feet from rock to rock. There's no way that that's happening. I am biting it and landing in that river. And I'm not making it across from a jump. And same thing happens with these electrons. They only like to jump so far. And when that distance expands too much, they get lost. Lost electrons, that's lost water production. That's lost ATP production. And that's an increase in inflammation. So this is where mitochondria matter. And this is where how we take care of those electrons and how they flow through our mitochondria, that matters. So here's the quantum perspective. The traditional paradigm is we only get our electrons from food. The quantum perspective is actually we get electrons from a lot of different sources. Those electrons could come from food, but they could also come from grounding. They could come from electron generation when our exclusion zone gets struck by ultraviolet light and we get this scattering, this creation of a plasma of free electrons, right? So there's a lot of different ways we can get electrons. And then via that 4th phase of water, we actually can funnel these electrons into the mitochondria where they get to that electron transport chain. And we hope that these electrons then flow from step to step to step. So we pass these electrons through each step. And at the end result, in an ideal world, they're actually making more of this water for us. And this water is an electromagnetic field antenna, right? It's a receiver, it's a sensor of what's happening in our environment. So it makes us very sensitive and acutely aware in our cells of what's going on, and we can respond to it. We make that ATP, we make carbon dioxide, really important for our planet, and we make infrared. So it's and that infrared heat then further structures the water into this exclusion zone water. So we get this beautiful cycle where we're working with the plants are giving us oxygen, we're breathing this oxygen in, we're taking electrons, we're funneling them from step to step to step, we're making water, we're making ATP, we're making infrared heat. Mitochondria run 10 degrees Celsius warmer than the rest of the cell because they're making this heat. And it's this beautiful self-sustaining cycle. It's a beautiful thing. Here are things that can disrupt it though, right? We have disrupted light frequencies. These sorts of things, a lack of red light or ultraviolet light changes how electrons can flow through the electron transport chain. When we get things that increase that intracellular calcium, it causes our mitochondria to swell and get bigger. It creates more damage, more inflammation. And that's the blue light, the non-native electromagnetic fields, the chronic infections, chronic stress, anything that drives that cell danger response can disrupt this process. Not having enough electrons, right? So that means we're in an indoor lifestyle. We have a heavy wireless tech use. A lack of DHA. DHA is a specific type of omega-3 seafood that has a strong pi electron cloud, it's called. So it hoards electrons basically for us. And so maybe we're not eating DHA and we're living inside and we're around all this wireless technology. That can be really, really an electron deficiency position. Anything that decreases easy water, our body's own production of it. So that could be lack of infrared, that could be grounding. That could be the wireless technology that actually we also know those non-native electromagnetic fields also will decrease that exclusion zone water. Poor circadian rhythm, lack of morning sunlight, anything that disrupts our body's ability to repair damaged mitochondria, which happens during something called mitophagy or autophagy. So if we're not getting our deep sleep, if we're not able to repair the damage, that naturally happens all day long, right? We naturally create damage that then while we sleep, we're supposed to be repairing. So if we're disrupting that because we're not getting good quality sleep, not getting into that deep sleep autophagy, and because of a poor circadian rhythm, then that can compound the process. And then any sort of chronic inflammation, stress, infection, anything that increases reactive oxygen species, toxins, those sorts of things, that's also going to impair our mitochondria. And this leads basically when a mitochondria becomes impaired, it swells, it gets bigger. And anytime a mitochondria gets bigger, what happens then to the steps that the electron's supposed to jump? Well, all of a sudden we've swollen them apart. And now those electrons have to jump farther and farther and farther, and they can't do that, right? And so it's this vicious cycle because we're losing more electrons, we're making less energy, we're making less water, we're making less infrared, and we're in the process, we're creating more damage to the mitochondria because those lost electrons become inflammation, reactive oxygen species. So what do? We got to gather electrons, right? You do that because by getting sunlight into your eyes and on your skin, we're barefoot, we're grounded, we're moving our body because movement generates electricity. It's called piezoelectricity. That's electron flow. And then for a lot of people, we can always talk about vegan versus carnivore versus whatever. I don't subscribe to a particular dogma of food. I've seen a lot of different things work for people. However, I think that DHA in a high-tech lifestyle, eating seafood is imperative because of the ability then to use the DHA to hold more electrons into your system. Losing electrons, we want to avoid these things, right? We don't want to lose electrons. We want the blue light exposure. We want to have wired technology versus wireless tech. So I've got, I couldn't lift it up because it's a wired mouse, wired keyboard. You see me with wired headphones, wired microphone, wired internet, wired. So if at all possible, wire your lifestyle here. And if we're sedentary indoors, we want to stay hydrated. We want to keep that exclusion zone water rich to hold on to our electrons more. So we want to drink the mineral rich water, breathe through the nose to get the oxygen to the mitochondria so they can do the best they can. Take movement breaks to generate piezoelectricity, electricity through the connective tissue, and then natural light breaks to set the circadian rhythm and get the important exposures onto our skin and into our eyes. And then a couple of just advanced things that, we can talk about cold thermogenesis, that's like cold plunges, and then ways to get infrared. We've talked about that, right? Because these infrared heat helps to maintain exclusion zone water. Exclusion zone water, because it's a denser form of water, it helps mitochondria hold their shape better. They're less likely to swell when we have that exclusion zone water adequate. It's like picture a water balloon, right? Picture a water balloon that's full of water, And then versus a water balloon where it's like full of jello, right? That jello is denser. It'll hold things in a stronger shape versus a water balloon where you don't have that exclusion zone water. It can expand easier. Okay, questions here, last little bit here. So I'll stop the share and go ahead. Let me see what I have here in terms of the chat, and then we can go into whatever else we want to here. I'll probably stick around until 3 o'clock. I don't hear any children knocking on my door just yet. So we'll see. We'll see how long that lasts. Cytochrome C, just a quick explanation. Okay, so cytochrome C, Laura, what you're referring to, for those who want a little bit more context with that, is cytochrome C is part of the electron transport chain in the mitochondria. Cytochrome C is that Dr. Cruz refers to as step 4 of the electron transport chain, which is where water is made. So that's where we make that water, step 4. And so it's called cytochrome C oxidase. And Dr. Cruz refers to it needing light because in order for electrons to flow through cytochrome C, red light and infrared light are needed, adequate amounts. So being inside really, really diminishes our exposure to red light and infrared light, which is why we can slow that electron flow, which is another reason why we're losing electrons. We're becoming dehydrated when we're living indoors because we're not getting enough of that red light and infrared light. Can you explain how DHA increases our photoelectric effect? Yeah, so DHA does a couple of different things, right? So DHA gets incorporated into our cell membranes. And so our cell membranes are basically just combinations of protein and fat. And DHA is a specific type of fat that can get incorporated into our cell membranes. DHA in particular has something that molecules have, like electrons that go around them, right? Electrons. And DHA in particular has been found to have something called a large pi electron cloud, which means just the ability to have more electrons around it. It creates almost like a storage, if you will, a depot of electrons. And so DHA, because it has that pi electron cloud, it allows us to assimilate more electrons from our environment. It allows us to have more electrons in our body. It helps us to, how do I want to put this in a way? It has less to do with the photoelectric effect in terms of sunlight striking a semiconductor. The photoelectric effect is when sunlight strikes something that semiconducts, like our connective tissue or our exclusion zone water, and that creates a plasma of free electrons, right? You create this electron generation from that. So DHA has less to do with that and more to do with the fact that it in and of itself is a very electron-rich molecule. I think it's the reason that our brains have a lot of DHA. That I think ancient humans ate a bunch of seafood, and that's how we were able to become the humans that we are, because DHA not only helps us to have more electrical connectivity or more electrical processes happening, DHA is also anti-inflammatory, so we can create these electrical processes without the added damage. So the other thing that's important about DHA is that DHA, we need adequate DHA in our eyes and in our bodies, right? DHA is a really important molecule that it does interact with light, such as vitamin A, melanopsin. And so when we're continuously blue light toxic, we're recycling our DHA from our eyes a lot more, because when blue light strikes the vitamin A and the melanopsin, DHA gets dislodged. They're all kind of connected, if you will, and DHA gets dislodged from that process and has to get recycled back into the eye. And so when we're staring at blue light all the time, we're depleting our DHA, we're forcing it to get recycled more and more. And if we're not increasing our sources of DHA, then we are potentially becoming DHA deficient. And then that's just synonymous with electron deficiencies, tissue specific to the eyes. Let me know if you have any follow-up questions on that. Does swimming in seawater or river water help us gather electrons and make more easy? Absolutely. Well, seawater, I love salt water, Allison, simply because it's like the perfect combination of we absorb so many minerals through our skin. People who have digestive issues, I always recommend using skin as a pathway, right? And so like a sea salt soak or something like that, or going into the ocean. Absolutely, that's an important thing. We're almost in like the perfect situation. Anytime we're in water, it's like this beautiful situation, because we're surrounded by minerals and nature and in something that has been bombarded with the sunlight and these beautiful frequencies from nature. But water is also a natural Faraday cage, so it shields us from the non-native stuff too. So it's like this beautiful It's a beautiful situation. Anytime we can be in bodies, natural bodies of water, I think it's a lovely thing. I don't necessarily know if it helps us make more easy, except for the fact that we're grounded, right? So it has that same grounding effect as if we were barefoot. So in essence, we're taking the grounding aspect of being in water and allowing it to build that easy for us. Do I recommend removing dental metals? I do, but you have to, Teresa, you absolutely have to make sure you use a trusted professional with that who knows biological dentistry and not just someone who is going to take your fillings out, because you can create, I've seen people create more harm than good by trying to remove mercury from their mouths, and it just got redeposited elsewhere, specifically in their brain. So I would say that yes, if you can get rid of, dental health is a huge one. If you can get rid of those metals, do so, but you have to make sure you have a trusted professional do that. Amazing info. Thank you so much. Watch the recording. Thanks, Kim. Thanks for coming. Appreciate that. Okay, let's see. Any other questions? We didn't do too bad. We didn't go too over.
I do.
Yeah, sure, Meryl, go ahead.
Okay, great. You mentioned the grounding mat. I was just curious, do you feel any difference when you use a grounding mat?
No,
Or-
I don't.
Okay.
I don't feel any difference when I do. No, I'll leave it at that. No, I don't. I feel way different when I'm barefoot in the middle of summer out in my backyard. But I think that there's a lot of other variables with that too that are in play.
Gotcha. Yes.
Have
So-
you read the Earthing book by? It's an easy read and it's a good read if ever you're interested.
Okay, I'll try that. So do you think, like, if we do red light therapy, we could potentially stack it, use a grounding mat and red light therapy at the same time to maybe make it more? Okay.
Yeah, I think stacking things is a really good way to go about life these days. You know, like what can I accomplish in this little amount of time? Like like when I'm going on that circadian walk that I talked about in the morning, it's like before I do that, I always do a couple maximal breath holds. I always do some lunges. Like what can I stack into it just to make sure it feels as beneficial as possible. So yeah, if you're already doing red light therapy, you might as well stack a couple of other things to that.
Yeah, just starting on that. So yeah.
Okay. Cool. Very cool though.
Yeah.
Awesome.
And then as far as like I know you there's no specific diet as such, but is it possible for you to shed some light on autophagy? I believe that or I read that it's a good way to clean up their cells, but then I think that's achieved, not primarily or most likely through ketosis.
Sure. There is for sure ketosis will help to stimulate autophagy. Fasting will stimulate autophagy. Exercise will stimulate autophagy. You have to get into good quality sleep in order to be able to stimulate autophagy. So I have seen, I'm not a proponent of a junk food diet, right? Let's just put it that way. I have seen tremendous benefit in terms of people getting into nutritional ketosis and people being on carnivore and people being on a really heavy seafood based diet. From a quantum perspective, if you're sleeping, if your circadian rhythm is strong, your sleep is strong, you're performing autophagy. By doing that, you will enhance autophagy with fasting then. So that would be the next thing that if you feel comfortable, people layer that on. I also, from a quantum perspective with diet, I always say local, if at all possible, right? Eat what was made or caught or even preserved in your local environment. And that's where farmers markets and becoming friends with local farmers, Eat Wild, a lot of those places, that Eat Wild website, eatwild.com, you really want to get in touch with what's available locally. My body can handle a ton more carbs in the middle of summer than it can handle currently right now. I can handle more carbs when I'm more active than it can right now. And I'm typically more active in the summer. So there's little nuances to it. That being said, I do know people who have done wonderfully well when they are strict keto or strict carnivore, something along those lines, and have had a benefit from autophagy, but there is wiggle room with that for sure.
Okay, great. If it's okay to ask, if someone is trying maybe try ketosis for a little bit, do you typically recommend doing some kind of detox on the liver, or because apparently it's a lot of fats and stuff to digest?
You got to be aware
Or-
of, you have to be aware of bile flow. I've seen people trying to go into ketosis with sluggish gallbladders, right? Yeah, or no gallbladder at all, and not having support with like ox bile or digestive enzymes. I've seen digestive enzymes really help with that.
Okay. Okay.
Yeah, no, I mean, I personally, I say that the phrase is redox before you detox. When you spend a month or two building up your exclusion zone water, and you build that exclusion zone, so your body doesn't have room for the toxins. You naturally start to get the toxins out of your body. And so I really feel like that, as opposed to doing a set detoxification program, no, but you do have to be aware of how your body handles fat, and going from zero fat to high fat keto, it can be an issue.
Yes.
So
Well,
just
thank
be
you.
aware. Yeah, for sure, absolutely. Let's see. Let me just see over here really quickly. Oh, you're welcome. Thanks for sticking around, everyone. Okay, so let's see. Cold therapy. How do you suggest cold therapy? Time. How to avoid catching a cold. Well, you know what? Interestingly, I say you start with cold therapy by dunking your face in cold water. No joke. Dunk your face in cold water, or instead of splashing warm water on your face with your morning routine or your nighttime routine, use cold water. Cold water on your wrists too, and the palms of your hand. So the palms of our hand, the soles of our feet, and our forehead have a specific type of skin called glabrous skin that senses the cold differently. So one of the best ways to start to get adapted to the cold is to expose those parts of our bodies to the cold before you full blow, cold shower or cold plunge. So start getting comfortable with cold on your hands, cold on your feet, cold on your forehead. I made some joke in the story, but I do this a lot, right? When it's cold outside, snow, I don't take pictures of it, but I should start doing it. My neighbors think I'm whatever. Cold feet, right? So until it's uncomfortable, but not unsafe, right? So this morning, my cold feet was 30 seconds. Like cold feet in the snow, 30 seconds. Cold hands in the snow lasted a little bit longer, maybe 45 seconds to a minute. Then I took a big old wad of snow in my hand and smashed it to my forehead. And you'll feel what uncomfortably cold but safe means. So you don't need to stay there until your lips turn blue and you're miserable, but you'll get a good cold effect because that's a systemic cold exposure. You'll feel those receptors everywhere getting cold, and your body will make note of that, and you'll start to get some benefits. So start there. Then if you want to, there's great benefits to a cold plunge. There's great benefits to a cold shower. I know people who think that is the biggest disaster nightmare. They'll never do it. So I don't want that to be a barrier, and know that you can get a benefit even from doing it in like little baby increments. That's how I did it. I literally started with like, okay, let me see what it feels like to just splash a bunch of cold water in my face. And so go from there. All right. Teresa, do you want more information on like the actual cold plunges? Let me know if you do. Okay. Any other thoughts or questions or comments? Yeah, sure, Meryl, go ahead.
Sorry.
No, go ahead.
A lot of, so in the case of a skin condition like vitiligo, now my child will be in school most of the day, so she won't have that transition period from no UVA to UVA, for example, and they're indoors all the time. So in instances like that, do you think like getting a UVA lamp or a bulb could help, or is that just...
No, it could, right? It absolutely could. That is one of those ones that I would have to know way more context, but I will put it out this way. Yes, it could. I have seen it help, but context is very important, and how that's layered and used with like red light therapy in conjunction with it and things like that.
Gotcha. And then, I see that like narrowband UVB is more studied for skin, even including vitiligo or any other skin stuff. But from a quantum perspective, like we said, narrowband is just a certain frequency versus UVB is like a broad spectrum. So do you have any thoughts on that narrowband versus UVB? And
well, yeah, that narrowband stuff has been used. I think that it's been manipulated in the scientific literature specifically to try to prove that ultraviolet light's bad for us. But it's hard, right? It's hard, right? It's like saying heat is bad, but that's because you stuck your hand on a stove for 10 seconds, right? And burned yourself. So it's like, it's how am I using it? What context is it being used? And unfortunately, a lot of the UVB literature uses that very narrow band for an insane amount of time while blocking the body's endogenous protective strategies. So I would say that you'll find a lot of research showing that narrow band is negative because of that. And then that's extrapolated to say all ultraviolet light is negative.
Mhm.
Now, there are studies though showing that certain types of ultraviolet light in various wavelengths excuse me, are beneficial in a therapeutic sense. Same thing, that's the same thought behind red light therapy. Red light therapy is not the full spectrum of red light. It's usually 2 to 4 distinct frequencies that have been really well studied in the literature as being beneficial for X, Y, and Z. So you could comb through the literature and say, for vitiligo, I do feel like this band has shown benefit in these ways, and then figure out how to apply that to your own unique N=1 clinical setting.
Oh, thanks.
Absolutely.
Yeah, even narrowband is, it requires a doctor's prescription, so it's hard to get it too.
Yeah. Especially because most people think that the ultraviolet light is going to exacerbate vitiligo when it's the exact
it's the reverse.
opposite.
Yeah. It's just so hard.
Okay, good. Let me see here. I think there was one last thing over here. A couple more. So there's Laura asked on fuel. Let's see, understanding it is less important than prioritizing the engine. Yes, Laura, you want to make sure your mitochondrial engines are healthy first, that they're revving on all cylinders. What do I eat in a typical day? This time of year, okay. So in Kalamazoo, this time of year, this morning, I had, so I saw my sunrise. I had made myself a nice, lovely cup of coffee. I put in we do raw grass-fed dairy here. It works perfectly for our bodies. So I have a bunch of heavy cream from this beautiful farm nearby. Poured that into my coffee. As I was sipping on my coffee, I had some local eggs, and my dad and mom make my dad and my aunt make kielbasa, so I had some eggs and kielbasa scrambled all together. Let's see, my kids, we do some homemade toast sometimes. So my kids had some toast with a bunch of butter on it. They love the grass-fed butter, so they just basically use the toast as a vehicle to consume copious amounts of butter. I had a scoopful of that butter as well. That was probably around 8 o'clock this morning. Before this, probably around 12:30 or so, I kept it super simple. I opened like a packet of tuna, or not tuna, a packet of salmon, right? Some just nice wild caught salmon, threw in a scoop of some primal mayo, stirred that all up, ate some of that just in the pack, super easy, with probably 3 handfuls of macadamia nuts because I can't put those down. Those are amazing. Love them, love them. That's what I've had so far today. Dinner, I have not planned that far ahead. There's some grass-fed beef up there that I might do some meatballs or something. We'll have to see what that looks like later on today. I think what we're going to do is take the kids sledding after this though. So I'll probably work up quite an appetite, but yeah, that so far, that's what I've had, Laura. I hope that helps. In the winter, I am way more local. I'm local. I'm more ketogenic or carnivore type stuff. What grows in my environment, what I can find at the farm, from the farms, the farmers markets, those sorts of things. I think that really matters. And so that's typically where I'm at right here. I feel like that is what my body needs to thrive. Okay, let's see. Oh yeah, raw dairy is so good. A book list. Okay, yeah, I will do that. So let me, by tomorrow, how about I'll have a book list. I'll have a couple of other things. Oh no, Trace, I do not eat after sunset. I find my digestion is horrible when I do. It's not worth it to me. My body is so in tune with eating with in a circadian mechanism. So hope this was helpful. I had so much fun chatting with you all. So maybe we can do this again with another topic. Feel free to let me know another topic you want to talk about more. If you just like this sort of a get together, that's fine too. So thanks for coming. I really appreciate it. You'll get that beautiful recording sent to you. I'll send you a book list, and I was going to send you a link to that water article as well. So I'll make sure all those get to you. If you need anything else, you know how to get a hold of me. So I hope you all have a very, very beautiful rest of your day, and we'll be in touch. Bye.
Thank you.
Thank you. So good to see all of you. Bye. Bye. See ya.